All right, today we're going to go ahead and we're going to finish up the matrices unit with this last section, matrices 3. If you haven't already done the bell work, will you go ahead and hit pause and start this bell work for me? Okay, so hopefully you took a moment to start this bell work or finish this bell work. If we look at numbers 1 through 4, we want to multiply them. So first thing we want to see if it's possible. We can see that the first matrix is a 2 by 2 and the second is a 2 by 2. Since these two in the middle are the same, we can see that we would have a resulting matrix of a 2 by 2. Thus, when we multiply them, I would go 2 times 1, which is 2, 7 times 0, which is 0, so that just leaves me with 2. Then we do top row times second column, so I have 2 times 0, which is 0, 7 times 1, which is 7. Now doing the same thing with the bottom row and first column, I have negative 3 times 1, which is negative 3, 11 times 0, which is 0, so that is negative 3. And then we have bottom row and right column, negative 3 times 0 is 0, 11 times 1 is 11, which we write right here, and we can go ahead and we can close that matrix. Doing the same thing, but now with number 2, we can see with this guy, the first thing I want to do is look at the dimensions. This is a 2 by 3 and this is a 3 by 3. These in the middle are both the same, so this means we have a resulting matrix of a 2 by 3. If I look, I go first row times first column. 1 times 0 is 0, 6 times 0 is 0, 4 times 0 is 0. Then I go first row, second column, 1 times 6, 0, 6 times 0, 0, negative 4 times 0 is also 0, so they add up to be 0. Last one, I have first row, third column, 1 times 0 is 0, 6 times 0 is 0, negative 4 times 0 is 0. Then I've got bottom row, first columns, 3 times 0 is 0, 23 times 0 is 0, 1 times 0 is 0. And then we're going to see this pattern repeats when I do the next 2 rows. So I'm just going to write 0, 0, and I go ahead and I close that matrix. Number 3, I can see that my first matrix is a 2 by 2, and I can see that the second matrix is a 2 by 3. I can see I have 2 2's in the middle, so the resulting matrix is going to be a 2 by 3. I'm going to go ahead and I'm going to write this out. So when I have this guy, I go first row times first column, so I go 2 times 1, which is 2, plus 7 times 3, which is 21. Now I go first row, second column, 2 times 6 is 12, plus 7 times 23, which is 161. Then I go first times last, so 2 times negative 4 is negative 8, plus 7 times 1, which is 7. Then we're going on to the bottom row with these columns. So I go bottom row times first column. So negative 3 times 1 is negative 3, plus 11 times 3, which is 33. Then I go bottom row, middle column. Negative 3 times 6 is negative 18, plus 11 times 23, which is 253. Then for this last one, I go bottom row, last column, so negative 3 times negative 4 is 12, 11 times 1, which is 11. I'm going to go ahead and simplify these by adding them together. So 2 plus 21 is 23, 12 plus 161 is 173, negative 8 plus 7 is negative 1, negative 3 plus 33 is 30, negative 18 plus 253 is going to be 235, and 12 plus 11 is 23. For our last matrix, again, I want to look at the dimensions. I see that this is a 2 by 3, and the second matrix is a 2 by 2. If I look at these numbers in the middle, they don't match, so I can't multiply them, so there is no resulting matrix. Or not possible, or whatever you put. Okay, for this last one with number 5, we want to solve for x and y. Just as a reminder, when we were doing this, is we can take this first row and we can multiply it by these two columns to create a system of equations. So I'm going to go first row times first column, which should get me negative 13. Then I go first row times second column, which should get me negative 9. So when I do that, I'm going to go ahead and I'm going to get 5x minus y equals negative 13. And then I'm going to get negative 3x minus 5y equals negative 9. To simplify this, I'm going to multiply this top equation by negative 5 such that my y's become opposite coefficients. So I'll go negative 25x plus 5y equals 65. I'm going to add those together, so I get negative 28x equals 56. Divide both sides by negative 28, and I get x equals negative 2. Then I'm going to go ahead and plug it back into one of these equations, so I'm going to plug it back into the top, so I get 5 times negative 2 minus y equals negative 13. This gets me negative 10 minus y equals negative 13. Add the 10 to both sides. I get negative y equals negative 13. Divide both sides by negative 1 to get, that should have been just a negative 3. Divide both sides by negative 1, so I get y equals 1. So I have x equals negative 2, and y equals, oh my goodness, equals 3. Sorry, holy cow. There we go. So you should have gotten x equals negative 2 and y equals 3. All right, let's go ahead and go to the next page. So again, kind of what we've been leading up to this is the whole point of matrices is it makes it easier to solve systems of equations. So we're going to see how we can solve a 2x2 systems of equations with a matrix. So the first thing we need to do is we need to learn what an augmented matrix is. An augmented matrix is a matrix of numbers in which each row represents the coefficient and constants from one equation, and then each column represents all of the coefficients for a single variable. So what we mean is we can see over here that we have 2, 2, negative 12, 8, and 8. The most important thing is just like when we were doing elimination before, our x's all need to be in line with each other, our y's need to all be in line with each other, and equal signs and equal signs. So that's what this dotted line is I just covered up is for, is that's to represent where the equal sign would go. Now, what we're going to do is we're going to see that a matrix is a reduced row form, and it satisfies the following, so that in each row, the leftmost non-zero entry is 1, and then the column that contains this one has all other entries equaling 0. In other words, this is a fancy way of saying that we're going to take this stuff right here on this left-hand side, and we're going to make it become the identity matrix such that all my 1s are down this diagonal, and then everything else is going to be zeros. That way we can see that this means 1x equals 2, 1y equals negative 1, and 1z equals 3. Now, we do perform what we call row operations, and it's very similar in what we would do with solving elimination. So we can see that that's what this is represented with right here. What this is saying I'm taking negative 1/5 and I'm timesing it by R1, which means row 1, and it's going to only change row 1. This is the most important part right here. We have to remember that this is the result, or which row is being changed when we're looking at this. So I can see I go negative 5 times negative 1/5, which gives me 1. 10 times negative 1/5, which is negative 2. 30 times negative 1/5, which gets me negative 6. And so basically all we will be doing today is we will be going from this leftmost, putting it into a matrix, and then solving for x and y. So if we wanted to think about this, if we are looking at this matrix right here, if I wanted to change 2 into 1, we would typically say, oh, that means I can divide it by 2. But I want us to not think that way just for the next couple of days while we go over this. What I want you to think of is this is the same thing as multiplying by the reciprocal. So instead of saying we're going to divide by 2, I'm going to say instead that we are going to multiply by the reciprocal of 2, which is 1/2. And that's how we want to think about this. So we don't want to think about division. We want to think of multiplying by the reciprocal. So let's look at this, for example, with number 2 on this next page. If we look, they've given us the same system in A, B, and C, and we want to figure out what they did. So first of all, when I look at this, the first thing I look at is to see which one changed. If I look, I can see that A1 and B1 are the exact same. However, A2 and B2 is where this changed. So I'm going to come down here to my answers right here. I want my result to be B2. So right here, this is B2 and this one's B2. That means that my result cannot be B1. So I'm going to go ahead and I'm going to cross that out. The next thing is I want to figure out, okay, did I multiply and then add equations together, or did I simply just multiply the equation? I always check multiplication first. So I can see that to get from -5 to 10, I could multiply by -2, which 8 times -2 is -16, and -4 times -2 is in fact also 8. So that means I'm going to pick this guy right here because all I did is I just multiplied the whole equation by -2. So similarly, now I'm going to see what happened to get from B to C. If I look at this, we can clearly see that C2 is the equation that changed. So I'm going to go ahead and I'm going to get rid of anything that's not a resulting of C2. So this one C2 and this one C2. So I'm going to go ahead and I'm going to cross these ones off. Next, I'm going to say, okay, did I multiply B2 by anything to get to C2? We can pretty clearly see that more than that happened because I got rid of my x's. Well, if we think about this, if we're getting rid of x's when it comes to elimination, remember that means I would take this top equation, multiply it by something, such that when I add them together, my x's would cancel and go away. So I need 2 to become -10, which means I would have multiplied it by -5. So let's try that. So that means I get -10x plus 35y equals, I would have done 13 times -5, which gets me -65. Well, when I add them, those cancel. Right here, this would result in 19y, and then 8 plus -65 would result in -57. So here I can see that I multiplied equation B1 by -5, and then I added it to equation 2 so that I could get the result of equation C2. So that's going to go ahead and be my answer for that guy. Okay, so similarly, looking at the next page, we're going to do it again. Again, we want to see what happened between system A and system B. So if I'm looking at these, I can clearly see that B1's my equation that changed, so I'm going to get rid of all my resulting B2 equations. Then from here, I'm looking and seeing, okay, did I simply multiply or did I multiply and then add? Well, if I look at this guy right here, a whole variable disappeared from A to B. So I can tell that I didn't just simply add them, so I'm going to go ahead and I can get rid of this top equation, and I need to figure out what in the world happened. Well, my x's disappeared, so I need to somehow make this -2 become the opposite of -6, which is +6. So I'm going to multiply that whole equation by -3, and that's what I'm going to put right there. Now for my next one, I can see that my equation C1 changed. So I'm going to go ahead and get rid of anything that is with C2 as the result. And I'm going to look at these again. If I'm looking at these, I can see that what I did essentially is I divided both sides by 11. So I got y equals -4. But remember, we don't want to think of it as dividing. We want to think of it as the opposite, multiplying by the reciprocal. So instead of dividing by 11, I'm going to think of this as multiplying by 1/11th. And that's the answer for that last part. Will you go ahead and will you try number 4 on your own and see if you can figure that out? So take a moment, pause the video, and see if you can figure that one out. All right, so if we're looking at this guy right here, we can see that A2 and B2 stay the exact same. So I'm going to go ahead and I'm going to cross this off because that means that it was A1 and B1 that changed. Looking from here to here, this is not going to feel very intuitive, or it's not going to feel like the most logical way to go about this, but what they did is they took this bottom equation and they multiplied it by 2, because that would get us 6x minus 6y equals 12. And if we look, when we add these together, negative 4 plus 6 is in fact 2x, 7y plus negative 6y is just y, and negative 2 plus 12 is 10. So in fact, they didn't just multiply by the 2, they multiplied by 2 and then they added it back to equation 1 to get the resulting equation of B1. Now in their heads, why I think they did this is for part C. So with part C, we can see that it's C2 is the equation that changes. So I get rid of C1 as my resulting equation, and I'm going to go back to C2. The reason I think they did this is because now if you multiply this top equation by 3, you get 6x plus 3y equals 30. Well, 6 times 3 is 9. Your y's would cancel, and it would equal 30 plus 6, which is 36. So we can see that once again, we didn't just simply multiply. We multiplied equation 1 by 3, and then we added it to equation 2 to be able then to get a new resulting equation of 3. So again, is that necessarily how we would solve the systems of equations? No, but that's the way that they had designed it, so that they could get y just to have a 1 out in front of it and make it a little bit easier. Okay, let's go to this last concept. This is called Gauss-Jordan elimination. So this is the goal of today, is to be able to understand how to solve systems with this process. So first of all, it's important to notice the goals are very, very similar and they have a repeating pattern. We're going to always see that our first goal is to make A11 equal to 1. So that's exactly what they did here. To get from this top matrix to this bottom matrix, you're going to notice that what they did is they changed 2 into a 1. So what they did is they took this entire row. Sorry, that's actually not how I want to write it. I'm going to write it like this. They took it like this, and they times it by 1/2. So they took row 1 and they times it by 1/2. So they got a new resulting row 1 to get 1, 2, and 8. My next goal, I forgot. The most important part is this piece right here. Row 2 stays the exact same. So I only change row 1. I don't change row 2 at all. Next, I want to be able to then make A21 equal to 0. So this is my next goal. How we are going to do that is we are going to see that right here, I have this 3. If I want that canceled, I need opposite of 3, which is negative 3. I'm going to temporarily multiply this top row by negative 3, so I get this result that we almost just like think of like on the side. So I'm going to write this on the side over here where I'm like, okay, if I take this top row and multiply it, I then get negative 3, negative 6, and negative 24. When I do that, I then add these 2 rows together. When I add those 2 rows together, that's how they got the new resulting row on this bottom of 0, negative 1, and negative 2, because they added these 2 rows together. Okay. So just like we would do in elimination, is they were like, we want to get rid of our x's so that we're just left with y's. So now why this is really cool is if we go to the next page, we can see that our next goal is to make A22 equal to 1, which, I mean, if we think about that, all we would have to do is we would just have to take this row 2 right here, and I'd have to multiply it by -1. So I'd go sorry, I thought that was my pen. -1 times row 2, which would get me a new resulting row 2 line. Again, it's important to note that row 1 stays the same. It doesn't change. So row 1 is going to stay the exact same. Now, once again, what we're going to do is my next goal, or my last goal really, is to then make A12 equal to 0. So for me to be able to do that, I need 1 to be opposite of 2, which is -2. So I'm going to take this bottom row and I'm going to multiply everything by the -2. So I get 0, -2, -4, such that when I add the two rows together, I go 1 plus 0, which is 1, 2 plus -2, which is 0, which is what I wanted, 8 plus -4, which is 4. Now, why did I do all this work? Great question, because you just solved your system of equations. If we look at this right here, we are saying that we have 1x, and that's the same thing as 4, and we have 1y, which is the same thing as 2. So we see that we get the solution x equals 4 and y equals 2. And the best part is you can go back and you can check your answer. You can plug it back in and make sure that this answer actually works and is something that you can get right. So when you're on your test, you can always go back and check your answers. Okay, so let's see what this looks like. Next page. If we're looking at this, what we're going to go ahead and do is we are going to go ahead and we are going to, first of all, just take the system of equations and put it into an augmented matrix. So if I'm looking at this right here, this means I'm going to write this out as -4, 16, -24 with the first equation. And then with the second equation, I get -4, 21, and -39. Remember, and this is the nice thing about Alex. Alex literally tells you your goal or what you're trying to get next. So it tells me that my goal first is to get A11 equal to 1. So for me to be able to pull this off, I need to figure out multiplying -4 by what will get me 1. Well, if instead of dividing it by -4, I'm going to multiply it by 1/4. Which when I do that gets me 1. I then go 16 times -1/4, which is -4, and -24 times -1/4, which gets me 6. Then for my next row, I don't change anything. And we can see this result right here literally only says R1, so I don't do anything to row 2 and I keep it the same. So I have -4, 21, and -39. Then next thing, I can see that now my goal is I want to change row 2 and I want 1 to be able to become equal to 0. So for me to be able to do this, I need to figure out if I multiply the top row by what number would the first two numbers cancel out to be 0. Well, I'd want opposite of -4, which is 4. So I'm going to multiply this entire top row by 4, such that I get 4, -16, and 24. So when I add these two together, I get 0. 21 plus -16 is 5. And then -39 times 24 is -15. Then I'm going to rewrite the bottom row, so I get rewrite the top row, so then it's still 1, -4, 6. Next goal, I then want to change this 5 into a 1. So I need to figure out what I'm going to multiply it by, which I'm going to multiply it by 1/5 so that becomes 1. So now all I need to do is multiply -15 by 1/5, which gets me -3. I then am just going to copy the first row because that didn't change. So I have 1, -4, and 6. Then last step, what I'm going to do is I need to figure out, I'm going to multiply row 2 by something, add it to row 1 such that I have 1, 2 becomes equal to 0. Well, I need it to cancel out with -4, so opposite of -4 is 4. Meaning I'm going to multiply the entire bottom row by 4, so I get 0, 4, and -12. When I add those, oh, I'm so sorry, I forgot to put my 4 right here. So when I add those together, I can see my -4 and 4 cancel to leave me 0. Then I go 6 plus -12, which is -6. My last number stays alone, so I just leave that as -3. This then tells me that I know that x equals -6 and I know y equals -3. Okay, let's go ahead and go to the next page and try it again. If I'm looking at this guy right here, again, first step is I just take the system and I put it in a matrix. So I'm going to write 2, -6, 16, 3, -13, and 12. If I'm looking at this guy right here, the first thing I want to do is I want to be able to change 2 into a 1. So for me to be able to do that, I'm going to multiply everything by 1/2. This then gets me -3, 8, and my bottom stays the same at 3, -13, and 12. I then want to figure out what can I do to make it so that this 3 becomes a 0. I need 1 to become opposite of 3, which is -3. So that means I'm going to go ahead and multiply everything by -3. When I multiply everything by -3, I get -3, 9, and I get -24, which when I add them, I still get 0. -13 plus 9 is -4. 12 plus -24 is -12. My top row stayed the same, so then I've got -3 and 8. Okay, so now if we're looking at this next step, I want to figure out how to change my row 2. So I'm going to go ahead and I'm going to multiply -4 by something to get to 1. That would be -1/4. So doing the same thing to -12 would mean that would result in 3. My top row stays the same, so I still have -3 and then 8. My last step is then to figure out how do I cancel out this -3. So I want it to become opposite, which is 3. So I'm going to go ahead and I'm going to write this out as 0, 3, 9, which when I add those together means -3 plus 3 is 0, and then 8 plus 9 is 17. And then my bottom number just stays the same at 3. This means I get the result that x equals 17 and y equals 3. Okay, we have one more example. I want you to try it on your own just so you can see if you can get through the whole thing or see where you got stuck, just kind of to self-evaluate and see how you're doing. So if you'll take one moment and go ahead and take a look and see if you can figure out that next one. Okay, so hopefully you took a minute and looked at this. Let's go ahead and let's look at this together. So I'm going to take this system and I'm going to put it into the matrix. So I get 4, 12, -32, -3, -14, and 14. From here, I'm going to go ahead and take this top row and I want to multiply it by something such that 4 becomes 1, which is going to be 1/4. This then results in 1, 3, -8, and then row 2 stayed the same, so I have -3, -14, and 14. Then on this next one, I want to figure out how do I make this -3 become a 0? Well, I need to multiply it such that they would cancel out. So I'm going to multiply this top row by the opposite, which is 3. So I get 3, 9, -24. So when I add them, my -3 and 3 cancel. -14 and 9 become -5, and then 14 and -24 become -10. And then my top row didn't change, so I still have 3 and -8. Next, I want to figure out how do I make -5 become 1, which I'm going to do the reciprocal such that I multiply it by -1/5. So that becomes 1. Negative 10 times negative 1/5 is going to get me 2. And my row 1 didn't change at all, so I still have 1, 3, negative 8. And then this last step, I want to be able to make it so that this bottom equation, that this top equation, that 3 is going to go ahead and cancel out. So I need to multiply it by the opposite of 3, which is negative 3. This would result in 0, negative 3, negative 6. So when I add them together, my negative 3 and 3 cancel, and then negative 8 and negative 16 become negative 14. And then my bottom one stayed the same at 2. So I can see that I have x is negative 14 and y equals 2. And that is solving systems of matrices with Gauss-Jordan elimination. You can go ahead and get started on your homework and your topics. If you have any questions, feel free to let me know. Thanks. Bye.